with testing web application scanners. This is kind of like an interim presentation because I don't have the results I wanted to get together for this presentation, but the results I have are useful, and I will go through the methodology. So. So, just a question: why would you want to benchmark a web app scanner? I don't know. The reason I would want, I kind of want to understand their limitations, determine the effectiveness on applications you care about, measure, identify performance and typical scan duration. I mean, in my case, there's a lot of applications I have to test, so I kind of want to know how a scanner is going to do if I have to keep using it over and over again in a large bank of applications. A little bit of you'll learn about the quality of the vulnerability detection engine and the quality of the false positive management. So my original thought was these are the scanners I want to test. So, and you're probably familiar with most of those. Those are kind of the big players in the commercial space, and there are a few scanners now, popping up in the open source space also. And I don't know. Has anybody tried Grendel Scan at all? What do you? No. Okay. I'm just getting started with it, so it's kind of a new thing. So for this presentation, I'm going to give data on actual real life data on AppScan, Spider, and W3F. I actually have results for the Web Inspect, but I'm not going to release them right today. And I'm going to release a paper soon, and I'm going to include Grendel Scan in that. And also, I want to try Acunetics also. I don't know. I just kind of learned about that one. So. No, this is new. It's basically, I did a whole bunch of applications. I chose two that are of the most stable, results, complete, 100% complete, which I went through, manually verified everything. So this is two complete tests that I'm pretty comfortable with. So these are the metrics when I run the scan. These are the metrics I'm trying to collect. So I want to know the true positives, which is actual real vulnerabilities, the false positives, false negatives, if I could figure them out, depending on the application. Sometimes false negatives you find by one scanner will find something and the other won't, and then you verify it, and then you know it's a false negative. So that's I think the biggest gray area right now, because there may be vulnerabilities in there that nobody knows about. Links discovered, and that's just basic spidering. How many links did the spider discover as it crawled through the application? Depth coverage. That's another interesting area, which I'm going to present some results on that, but I'm not 100% sure what that means right now. I'm still trying to figure it out. But the tool I'm using, actually a tool from Fortify on this, and I'll talk a little bit about it. There's a statistic I thought about, signal to noise, which I take the vulnerabilities found and divided by the false positives. Basically, it's how much junk you have to wade through to kind of make sure that these are actual vulnerabilities or not. That's kind of that. And efficiency is the vulnerabilities per time. Like how good is the scanner at finding vulnerabilities quickly? That's another. I actually haven't had a very good experience with that, but. I'm still trying to collect that information. Yeah. So links crawled, that's the actual number of accessible links that tool was able to discover and access. And coverage, yeah. So coverage actually is, and the way I'm using coverage right now is I'm basically using a tool that actually instruments the application. So it basically adds code to the application that monitors functions within the application, and functions usually that are security critical, that, you know, like data flow functions that have sinks and input. So it does give you a measure of how well the scanner does in accessing the application, because the code wouldn't the code that's injected into the application won't trigger unless it executes. So you know that if you start getting coverage counts, you know that code is executing inside the application. And it's also generally defined as a ratio percentage. So what will happen in the tool is it'll actually add this code to the methods inside, or the functions inside the application, and it'll tell you how many of these it added to the application. And then it'll tell you how many of these were actually triggered. So you actually have this map of you know, what was actually triggered in what did the scanner actually trigger inside the application. So it's interesting. And then you can also see all the files that those functions were actually in. So you can see which files and which functions and methods were actually triggered. So it's an interesting statistic. Yeah, so positive and negatives. Those are positives, a real vulnerability finding, false positive, you know, non-existent vulnerability finding, false negative. Yeah, so, and that's something that exists but was never found. Did I do that twice? Oops, sorry. Oops. All right, there we go. All right, so additional measures. So another thing I do sometimes, and this is more to find the false negatives, is I take a source analyzer, some kind of static analysis, and you go through that also. Sometimes I find additional stuff, and I can add it to the false negative. So this particular application does have a few of those in the statistics. This test. All right, so benchmarking web application scanners is not an easy task, and these are some of the reasons why. The scanners exhibit non-deterministic behavior. So I've discovered that as I've been doing this test that there's almost like a golden rule. You can never have this run the same scan twice. So you're always going to have a little bit of a difference, but you want as least of a difference as possible. So you're gonna probably, and at least in my case, I usually redo the scan a few times until it's stable and I'm comfortable with the results.
So is that because the scanner's behaving differently, or the website's responding differently?
It's hard to say exactly what's causing it. I don't know. In your experience, do you get the same scans always the same? I mean, I don't know. I rarely do. Really? Maybe it's because you work on a single application.
A small number of applications.
Okay.
Sometimes it can matter if you get different results if you're just scanning something on your local network as opposed to scanning something over the internet and places, network latency and issues with cost timeouts and things like that. And that should do if you're not
Right.
scanning remotely.
Yeah, I mean, I've had the same experience whether I'm scanning remotely or locally. So I don't know. It's interesting though. It's something I'm trying to deal with. I mean, the results-wise, I usually get the similar results or similar enough that I'm comfortable with it. So, but I'm saying I do have issues with getting the same scan, exactly the same scan always. So, then if you are adding a coverage tool, that adds significant overhead. Sometimes it takes me a while to get the application stable once I add the tracing coverage tool to it. So there's that. And sometimes the scanner logic works really well on one application and is completely ineffective on another. I mean, this isn't true for all scanners, but it's true for some, and maybe most actually. But sometimes the scanner will do really well on one app, and then another app it'll find nothing. Also, if the application has really, really, really poor error handling, you're gonna have a lot of problems. Scanner. Good. The scanner is in recovering, and some scanners will just stop. If it doesn't like what the application is telling it, or if it's getting too many errors, it'll just shut down. So that experience also. Comprehensive scans take a long time. I mean, sometimes it's as long as 8 to 12 hours if it's a really fairly large application with a lot of a lot of JavaScript and stuff. I haven't had good experience with portlets. I don't know if anybody here scanned portlet-based app. Yeah, I haven't had. Actually, the results are unusable. Actually,
What do you attribute that to?
I don't know. I'm not sure. I mean, probably somebody else in here might know.
We're trying to figure it out, but they just fall over.
Right. Yeah. I was actually testing. I was going to try to test a portlet application for this presentation, but it was not possible to do. So that's interesting. So that's the thing. You know, when you're using a web app scanner, you may not work on your application. You know, that's why you really want to test it before you, especially if you're purchasing something, make sure it actually works. And then sometimes vendors especially vendors don't like it when you're comparing scanners and then you want to talk about it with a lot of people. So that's another issue that sometimes comes up.
Is that why Sensic and HP are not in your guidance?
Exactly. Yeah. So these are the applications I used in the benchmark. Yeah, we'll see. We'll see. I haven't talked to the Acunetics yet. We'll see what they have to say. So I used I have more results than this, but for this particular set of results, this is what I'm going to present: Apache Roller 4.0, and another Java application, which is an extreme programming. That's not really a portal, but it's like an extreme programming kind of management application where you can set up your stories and put all your users in and how they work together and all that stuff. It's an interesting app. It's got tons of JavaScript and all kinds of junk in it. I used Fortified Tracer 2.0 for coverage analysis. Yeah, so I focused on Java applications so I could use Fortified Tracer. Now, actually, I'm going to start working on some .NET apps. So I finally got to the point where I can start doing .NET apps. So that's coming, and Fortify supports .NET also, so I'll be able to have some results on that also. These applications, they had some meat to them, and they were not that complex, and scans could go through fairly smoothly. And then they played well with the tracing application, which isn't always the case. That's my server environment. It's AMD 64, Debian Linux 9 in Zen virtualization, Sun JDK 1.5, and MySQL 5.0. So I'm going to talk a little bit about trace analysis. And there's two types of trace analysis, static weaving and load time weaving. Actually, in the first paper I did, I used static weaving, where the code's added to the application, and you have the compiled binary or byte code in the Java case, and then the weaving application will add the monitoring code to the byte code. Yeah, so it's actually I use post-compile weaving for the last one. And then there's load time weaving, which I used in this one. Load time weaving is kind of interesting. So it is the same post-compile weaving, except it's done as the classes are loaded into the virtual machine. So, and one interesting thing about it, I noticed, and with this load time weaving is when classes are loaded, sometimes other supporting classes are loaded too. So the environment will have new it'll add code to stuff that when you initially loads up, you'll have a certain amount of code that was added as monitoring code, and then suddenly you'll have more. As more classes are loaded, you'll see it appear in the Fortified console. There'll be like maybe 200 or 300 more endpoints that were added. So it's interesting that it's got this dynamic thing. And that's basically what you have: the class file, and then you have the methods, and the aspect is actually the monitoring code, and it sits. It's compiled in there, and depending on how it's coded, it's capable of grabbing the data before the parameters before it enters into the method, after it enters into the method, or both. So it's able to operate on that. And usually, what I've seen is, they'll put some regular expressions in there or some other type of logic to try to detect not only if that was actually triggered, but is there even a vulnerability in there? So the tracing tool actually is able to actually discover some of the vulnerabilities. So I think actually this is for at least for bytecode based applications, this is kind of like the beginnings of a possible internal application based security system. And I think that's going to be coming down in the future. Just some of my observations. I think in the future, I think security systems probably will be inside the application rather than outside. I think that's where it has to go, rather than sitting in front of it on a network. Okay, so here's some of the first benchmarking statistics I have. This is for the XPlanner app, and this is a little bit about what I discovered. So for NTO, 249 links crawled. Now, here's a strange thing I don't know about AppScan. I actually, this was for the last scan I did. I actually initially got more links crawled. The first test I did in less the second, but the results were the vulnerabilities found in the results were exactly the same. XSS found 30, SQL injection 1, false positive 5, false negatives 2 for AppScan, NTO 14, SQL injection none. No false positives though on this one. That was interesting. And false negatives 19. And the reason I put a star on W3F for links crawled is because W3F can't automatically crawl JavaScript and Flash, Flex. You have to actually do all that manually. So you have to manually crawl the application, and then based on that, it's able to process the JavaScript. It's a little strange, but that's how it works.
What was the actual number of vulnerabilities?
That's the actual number. Okay, 14 and 31.
Yeah, the actual, not what the scanner found. How resistant is that?
Oh yeah, well false negatives, right? So
Oh, okay, yeah.
32,
Okay.
33 actually.
33?
There was 33 vulnerabilities in this one. So false negatives are the ones they didn't find. So they don't find all the problems. And here's Roller. This is the second one.
Were you just looking to classify cross-site scripting and SQL injection, or were there other vulnerabilities?
There was some informational configuration type stuff, but I usually don't consider those real vulnerabilities. I know it depends. So I usually, when I do the benchmarking, I'll only go with cross-site scripting, SQL injection. I mean, if it's something particular to how a particular web server was configured, because these are web server independent applications. So I don't usually there's a lot of environmental issues like that. They're never as a high though. But so yeah, so if you were concerned about your Apache configuration or something like that, if file uploads, yeah, I would say those are a vulnerability. You could, but I didn't have any of those in these apps.
Any other injection type vulnerabilities?
No, this is all this app has. Yeah, that actually I was able to verify. Yeah.
That was my question. How do we know that this is the only vulnerability?
We don't. I mean, these are the ones I was able to verify. So yeah. So I actually went through all the output that the scanners had, and I manually verified them all. So as far as what the scanners reported, that's what this bit mostly is. I mean, and I did do some static analysis too. So and this, I mean, I missed some. It's not perfect, but it gives me a sense. This gives me at least for me, it gives me a sense of what the scanner can do, and compared to other scanners, and I like that. I like to be able to have, what am I dealing with when I'm using the scanner? That's what I mean. That's what doing these studies has done for me. It's let me really, understand what I'm dealing with, and I can't just put like blind faith. It's like dispelled my blind faith, which is good, I think. So.
Did you benchmark the HP and just not?
I benchmarked the HP, but I'm not releasing the results because they don't want me to, and I.
Does this confirm or negate the results of the other?
No, actually, I mean, I'll be willing to talk about it offline if you want.
Okay.
If you want to know what happened, so I'll do that. So these are actually my tracer statistics. Now, these are interesting statistics. I'm still kind of digesting it though about what does it really mean. It's a fairly specific statistic though, because you can't get these statistics on these unless these aspect logic is actually triggered. So, but you'll notice what's interesting. It's always for sort of inputs to the application that the scanners only trigger a small percentage in most cases. And all endpoints, for instance, that's where data is actually written, like a database or a file or something like that, or a stream. If it's written into a stream, so an entry point is an input, and then an endpoint is some type of writing to a stream operation. So writing to memory, that kind of stuff, writing to a file. Yeah, web entry points. That's the actual, HTTP client, variables that are actually that the tracing logic was, that could have been modified in the application. And here's the same thing for roller. It's interesting that though, comparing like it seems like the scanners did much better on coverage on this application as compared to that application. I see that a lot too. And it doesn't. Another interesting thing is it doesn't correlate to the vulnerabilities found either. That's another thing. Just because a scanner does a really good job of crawling or covering the application doesn't mean it's going to find or does a good job of finding vulnerabilities. So though you can't really correlate those two either. But at least it gives you a sense of how well is it seeing my application. So that's what I find interesting about it.
Okay, so one question: if you try to analyze the web entry points, so 7%, does it tell that it's not able to find those URLs to start with?
What it'll do is it'll tell you the file that entry point is in. So yes, you can go into the coverage tool and you can actually find, like, see this all 81. It'll tell you what file it's in and what method and function was actually covered. So if you really want to know what the entry point is, you can go into the application and find it. And if you have the source code, you can actually map it to the source code. You actually find the exact source file that entry point is in and what the logic of that entry point is. So if you really want to get into it, you can. That is one nice thing about coverage. It actually lets you get really down deep inside your application.
The reason I asked is 7% looks too less, especially if we talk about web entry points, right? It should somehow correlate to what was my coverage on the URLs which were exposed and how much it could find, right? If it could find all the URLs which could have been accessed.
Yeah, but it actually, it's not just the URLs, it's also all the parameters. So these are all the actual parameters in the URL also. It's not just the URL itself. Yeah. And any type, and also other types of logic that like in the GSP will have some kind of write logic in it. I mean, it's you have to think about it more as a programmatic method rather than just the URL.
So to take an example, if I have one URL which has say 20 fields to be inputted, so write only 7% of them. Or 3%.
Exactly. Yeah. And not necessarily even all the parameters. It's like operations on which of those parameters, right? So if it's a write, if it writes to if the JSP, let's say, writes to these parameters or sent or outputs certain types of parameters or reply certain type of reply data. So yeah, it's actually the functions executing inside the application, just the parameters themselves. Parameters are that's just data that the methods use. This is the actual function logic that's being measured. So there's a little subtle, yeah.
You mentioned that the WSPAF, you're not capable of doing automatic explore, so you're doing manual explore.
Yeah.
So what exactly does it mean?
Oh yeah, that's a good point. So this is actually when I manually went through the application. This is and I tried to be fairly thorough, and that I was getting that. I just thought that was interesting. Yeah.
So the other entry points were not really accessible?
It's possible. It's possible. Yeah. These are the entry points that the tracer application decided to add aspect logic to.
Are they visible to the outside?
It's hard to say. I mean to really I didn't go into that much detail to really. I mean you could go in there and really the data flows in there. You probably could tell, but it's not. Yeah, you're right. It doesn't mean so just because it could be only 18% of this application or whatever is actually really accessible by user modifiable data. It's possible that some of these entry points are completely unaccessible or yeah, it's true.
These numbers are under the assumption that supported by coverage tool is giving the true results or true statistics on the entry point.
Yes.
If you try to create a single servlet with a single entry point, saying that it actually shows the number 1, you can actually trust it because these numbers seem awfully low.
Yeah, no, I haven't, and actually that's.
Interesting to see.
Yeah, that's a good idea. Actually, I should do that. You're right. I know I haven't done that, and like I said, this is kind of the beginnings of something interesting. That's the way I see it. I don't trust it 100%. I'm just putting it in just because these are real results I got, and I want to start really understanding what's really happening here. I think there is something going on, and I think something that's worth further consideration. I'll leave it at that. Right now, make of it as what you want, but these are real statistics.
It's surprising how time-consuming something like this is.
Oh yes, it is very time-consuming, especially if it's not what you're doing for work in your main time. Yeah, but I have to admit, it does help you. Doing stuff like this does help you appreciate and understand what this application is really doing. And then especially if you have, like for me, I don't have a specific application I work with every day and that I have to protect or something. I do more just generic stuff, or I go through many applications, so I can't really understand an application thoroughly. But doing stuff like this, especially if you do it on a single application, if you do it enough, you really start understanding what the application is and what it does and how to protect it and stuff like that. So I think it's useful for that kind of, stuff. And this is just so I basically took all the false positives and divided the vulnerabilities by the false positives. So that's what I got there. And as far as efficiency goes, like I said, so just because the scanner finishes quickly doesn't mean it's going to find the most vulnerabilities either. So I found that AppScan was the slowest, but generally gave me the best results. So that's another interesting thing.
Were you using the latest versions of the application?
Yeah, these applications are all open source. They're all you can you could reproduce it.
No, I mean the AppScan and...
Yes. I don't know. Did I put the versions I was using?
I don't remember.
Yeah. I think I may have missed that. But yeah, I was using the latest. The build of AppScan I was using is probably when I did this they're both last month builds.
Okay.
So they're very new of all these apps. It's like AppScan 7.7 something. I don't know what the latest build is. It was 7.7 something, and NTO was like 3 something. They're all very recent builds. Yeah. And if somebody sends me an email and you want to know exactly, I'll tell you. I just forgot to put it in the okay. So these are some other observations I've had. So the amount of links crawled or the coverage of the application doesn't always correlate with the ability of a scanner to discover vulnerabilities in a specific application. So that's, so, yeah, so a scanner may have good efficiency, yet find less vulnerabilities in a scanner that takes much longer. You know, scanner, like in W3F, it found, you know, nothing in one and found decent amount in another. And I have very interesting stories to tell about WebInspec. Hopefully one day I'll get to talk about it. Especially in that particular bullet. And you can't, like, the last time I did this study, I actually didn't even really tune it to scanner as much, and so I definitely had some problems. So you definitely tap the scanner quite a bit before you can actually get an effective scan. So don't use a scanner out of the box. So that's something I learned in a hard way. So I am working on some more testing. I just started on ASP.NET, Java. I got a whole bunch of Rails, PHP, Flex ActionScript apps I want to start working on. So, and I hear that some of the scanners are going to have some capability to handle this stuff in the near future. And then I don't know if I'll be able to find any tracing logic for Ruby and PHP. I know there's some AOP stuff out there for PHP and Ruby. I don't know how useful it is. I'm probably going to have to customize it for myself. So yeah, so there's some apps with Dojo and REST. So I'm going to start taking a look to see how those things work. But also because of some of the performance issues I had, I'm building a much better box. So this is speed it up. Okay, so these are my conclusions. I'd like to reiterate that benchmarking scanners is hard. You have to do it in a very high performance environment. Be ready to swap operating systems, applications, servers, and databases in and out. In my experience, the scanners miss large portions of the applications. Scanner performance from application to application can be like night and day, especially if a different framework is used. Yeah.
On the part about missing large portions of applications, I found with the scanner I use that I almost always like to map it out and where I go, and
Sure.
you get much better coverage.
Exactly. And that's a good.
It doesn't take that long necessarily for the.
Right. So I agree with you. If you're doing this purely on one application manually, you probably the way to go. I just want to see. I'm for this. I'm more interested in benchmarking, right? So I want to see, I get this scanner going. I want to see how well it can do on its own. I mean, I do want to see that because a lot of these scanners are sold that way, right? So that it's going to help. It's going to find and they do have crawling engines. So you want to see how good this crawling engine is. So there's that.
Yeah.
So yes.
It seems like you're almost testing two different things.
Right. Yeah, I mean, when you're testing the crawling engine, you don't want to manually crawl. You want to manually crawl as least as possible, right? So if you're actually testing that capability, but if you're just trying to, test and secure your application, then yeah, you do want to do everything you can to make the scanner more effective. Yep.
Question, I had a experience more than once with AppScan where I'm scanning a really large site, and I might get anywhere from 5 to 50% through crawling it, and I run out of memory. And it's on a big server, or just like there's like a like in a car, a truck, a governor.
Running out of memory on the scanner system or on the back end?
On the scanner. So you hit a wall, and it just isn't going to let you.
You're right, and that's.
Did you experience that with the other scanners?
I experienced it with every scanner.
They'll hit a wall.
They can, and then yes, and then you're only it depends on where you hit the wall. If you hit the wall on the server side, on the application side, that can happen. The scanners, especially if what you could do is actually what I found is sometimes the scanners are tunable, so you can use less threads. So sometimes it uses a lot of threads and it's hitting the application with many processes. So see if the scanner, and I think AppScan has this, where you can lower the amount of threads then you'll have to go down to 2 threads, because I think something like 1 to 12 threads it has. So I think the best bet, if you're experiencing on the client side, then probably either get more RAM, faster CPU, or lower the thread threshold. And on the server side, you just got to get a bigger box. And I've had experiences with some of these applications where I just need more RAM and more CPU to really do the scan right. So yeah, that's interesting. Sorry?
It was just really a box hosting multiple apps and just get hold on.
Because I've run into issues with ASP.NET apps where every page posts back to itself. So if you have a website with hundreds of pages and you go run an automated scan, it results in a huge scan that can run out of memory. But then if you take that same site and do a manual crawl of one example of each piece of functionality, you actually get much better results in a much shorter time.
Yeah, that's true. So that's an interesting thing. It's like, should you rely on the crawling engine? I don't know. Depends on your situation. I was like trying to measure how good the crawling engines are, but in a real world case where you're just trying to secure an application, that's irrelevant. I mean, what you're trying to do is secure the application, trying to get good results from the scanner. That's really most important on an individual basis, I think. Okay, so is there a winner? All right, I don't know, it's hard to say, but based on my results, I would have to say right now AppScan's doing the best. It's gonna be slow, and it's pretty stable, and has a decent detection engine. NTO also I get pretty good results with NTO, but also I have issues with some of the builds. So sometimes it takes me a while to get a build that I'm happy with, but they're easy to work with. So I mean, these are from all the scans I've done with all the different scanners I've used. These are my favorite scanners. They give me the best results, and I find them useful. And these are some people have helped me on this round, so I want to give them a thanks. And that's it. I'm done. If you have any questions.
So you were talking about the next steps on kind of Web 2.2 and JavaScript kind of.
Yeah.
So do these vendors claim currently a good coverage on those?
It's an unknown. Not real. I haven't heard anything. I mean, we'll find out soon enough. No, there's no real claims. I think it's a new chapter opening up in a new set of problems. Yeah. So right now, I think it's kind of. I think some of them are working on it, but it's a difficult problem. So I don't know how successful they're going to be. I think just the scanner vendors that have the best people and expertise are going to make it, and then it's going to get really tough. That's the way I see it, at least.
Vendor